Start with the basics. Chemical reactions are processes where substances called reactants transform into new substances known as products. These changes are all around us, from the rusting of iron to the digestion of food in our bodies. In a chemical reaction, bonds between atoms are broken and new ones are formed, resulting in different materials with new properties. For example, when magnesium burns in oxygen, it forms magnesium oxide, a classic reaction you might see in a lab. Chemical equations are used to represent these reactions, showing the reactants on the left, the products on the right, and an arrow indicating the direction of change. Understanding these equations is key to grasping how matter changes in our world. Now let's talk about balancing chemical equations. In any chemical reaction, the law of conservation of mass tells us that matter cannot be created or destroyed. This means the number of atoms for each element must be the same on both sides of the equation. Balancing equations ensures this rule is followed. For instance, when zinc reacts with sulfuric acid, it produces zinc sulfate and hydrogen gas. To balance the equation, we adjust coefficients so that the number of atoms matches on both sides. This step is crucial for accurately describing what happens in a reaction, whether you're working in a classroom or a laboratory. Balancing equations helps chemists predict the amounts of substances consumed and produced. Chemical reactions come in several types, each with unique characteristics. Combination reactions involve two or more substances joining to form a single product, like hydrogen and oxygen forming water. Decomposition reactions are the opposite. One compound breaks down into simpler substances, such as calcium carbonate decomposing into calcium oxide and carbon dioxide. Displacement reactions occur when one element replaces another in a compound, like iron displacing copper from copper sulfate. Double displacement reactions involve the exchange of ions between two compounds, often producing a precipitate. Understanding these types helps us predict reaction outcomes and their applications, from industrial processes to everyday life. Chemical reactions aren't just confined to laboratories, they're part of our daily lives. Rusting of iron, cooking food, and even breathing are all examples of chemical changes. For instance, when iron reacts with oxygen and moisture, it forms rust, a process called corrosion. Similarly, the browning of cut apples is due to oxidation reactions. In the kitchen, baking a cake involves numerous chemical changes as ingredients react to form new flavors and texture. Understanding these reactions helps us appreciate the science behind everyday phenomena and can even guide us in preventing unwanted changes, like using antioxidants to slow down food spoilage. Summary: chemical reactions and equations are the foundation of chemistry, explaining how substances interact and change. By learning to write and balance equations and recognizing different reaction types, we gain insight into both the natural world and industrial processes. From the air we breathe to the technology we use, chemical reactions shape our lives in countless ways. Whether you're a student, a scientist, or just curious, understanding these concepts opens the door to exploring the fascinating world of chemistry and its impact on everything around us.